The International Surface Water and Ocean Topography, or SWOT, is the first satellite mission to observe nearly all water on the Earth's surface. It will help researchers address some of the most pressing climate change questions of our time. It is now undergoing final preparations for its December 12th launch. Welcome. I am Marina Jureka with NASA's Jet Propulsion Laboratory in Southern California. The SWOT mission is a collaboration between NASA and the French Space Agency, Centre National d'Études Spatiales, or CNES, with contributions from the Canadian Space Agency and the UK Space Agency. SWOT team members from NASA, JPL, and CNES are here to give you an update on the satellite and discuss why we need the data it will collect. On our panel today, we have Tahani Amer, NASA's Program Executive in the Earth Science Division of the Science Mission Directorate. Thierry Lafon, Senior Project Manager with CNES. Parag Vaze, Project Manager at JPL. Lee-Lueng Fu, Project Scientist at JPL. And lastly, Ben Hamlington, Sea-Level Researcher at JPL. Later in the program, we will take media questions. Remember to press *1 to get put in the queue. We're also taking questions through the hashtag AskNASA. I'll hand it over to Tahani Amer for more on this mission and the international collaboration. Tahani?
Thank you, Maria. We're very excited at NASA because we are preparing to launch SWOT on December 12th in SpaceX Falcon 9 rocket at Vandenberg, California. Why are we excited about SWOT? Is because it is will survey nearly all the water of Earth's surface for the first time, which implies it is the first satellite to do so. And it will address questions that we have around Earth's climate, providing data that will help us inform decision about our everyday life. What is SWOT will do? It will measure the heights of Earth's lake, rivers, reservoir, and of course, the oceans. And it will help scientists be able to track the movement of the water around the world. We know that water is essential and is very important, and it plays a crucial role of how to store and move Earth's heat and carbon that influence our planet, weather, and climate. SWOT will help us to know where is the water today, where it's coming from, and where it is going. It is critical to the scientists to understand how the planet water resources are changing that impact those changes that will affect our local environments, our local people, and internationally. Climate change is also speeds up the water cycle on Earth that lead to extreme weathers, that events that like heavy rain, extreme drought that can be very hard to community, and we need to understand that to be able to manage water resources. Now let's talk about the data for SWOT. SWOT will provide a lots of data, data that will be scientists, engineer, water manager will be using to be able to understand the climate changes. Now, all this data will be free and will be available to everybody to use. That is really NASA's policy. Can I get the next visual, please? Now, we have been working with our team at CNES, international partnership with CNES for a long time, and it's been a very fruitful relationship to understand the Earth and its climate. CNES and Thales pioneered the use of space-based instrument like altimetry, and we since Poseidon and since 1992. And we are here now with SWOT to be able to measure and use detailed information about the ocean and understand our Earth's water, almost nearly all Earth's surfaces. Now, let's observe the planet. NASA observed the planet Earth from space. We have probably a couple of dozens of satellites that orbiting Earth that measuring all kind of measurement for our Earth to understand a planet. And SWOT will be one of them to be added to this fleet and will be launching in December 12. Now, I would like to add to I would like to share this information with you that this SWOT will be part of the Earth observing system that's coming up, that will be the future of our Earth observing system that NASA is working on. Let me tell you, SWOT is a game changer, and the water connects all of us, and we're very excited to share the data for SWOT. Therefore, go SWOT, and I would like to give it to my colleague Terry.
Thank you, Tahani. Thank you for your presentation. My name is Thierry Lafon. I am the lucky SWOT project manager at the French space agency CNES. I would like to address a very important aspect of the mission, which is cooperation between France and the United States. I have the chance of being part since almost 30 years ago of this emblematic cooperation between our two countries for a better understanding and monitoring of the Earth's waters. NASA and CNES have been continuously working together since the 80s to imagine and implement the future of altimetry. The first picture shows NASA and CNES people in the White Room for SWOT. The first mission in cooperation was Topex Poseidon, and Lee Fu will describe that later on, was launched in 92 aboard the European launcher Ariane. It was followed by Jason 1 in 2001. Here's another pic showing myself with Gassem Asrar, NASA Science Deputy Associate Administrator before Jason 1 launch. And then we launched Jason 2 in 2008. There's another picture of me with Parag Vaze, my colleague on SWOT, in 2008. And then we launched Jason 3 in 2016. So we've been discussing about altimetry. What is altimetry? Altimetry from space is a technique which finds its origin in the 80s. The basic principle of the classic altimetry mission is to measure the round trip of a radar signal sent by the satellite and reflected by the water surface. Of course, to achieve an accurate water height measurement, we need specific instruments on board, and especially instruments that help locate the satellite within 1 centimeter at nearly 900 kilometers altitude. The SWOT measurement will also use a radar signal and the reflected echo, but in a slightly different way, called the radar interferometry, which will be explained further on. Coming back to SWOT, I am working on SWOT since the beginning in 2008, when a group of international scientists proposed a new Earth water mapping mission at a resolution that never seen before. CNES and NASA decided to pool substantial resources to develop together this $1 billion mission. As a result of the work-share agreement between the two countries, CNES, together with its subcontractors, would deliver some mission instruments to JPL, realize the satellite integration and testing activities in Thales, Cannes, France. Then we would operate the satellite on orbit and finally manage the daily production of processed data. As a project manager, I'm really committed to reduce any mission risk, but sometimes our business has to cope with unprecedented situation. As we were working at JPL in late 2019, the COVID pandemic struck. And I had to take rapid decision to get my team back in France as the international flights were about to be cancelled. Then, with my colleague Parag, we were at the point to ask ourselves, shall we wait until the COVID situation improves to resume activities at JPL? But we didn't have any idea when. Or shall we find a solution to be able to work remotely from France and proceed? Yes, so all the teams joined their efforts to find out practical ways to be able to protect the schedule. And we were able to successfully complete a complex integration and testing period at JPL then followed by a 14 months of testing in Thales premises in France, before we shipped to the launch base where SWOT is now. That was really a great demonstration of resilience and inventiveness of our teams. It becomes evident that Earth science international cooperation is necessary to improve life on Earth. Such an ambitious and challenging mission like SWOT could only be made possible by bringing together the skills of scientists and engineers to mutually enhance our ability to observe changes in the Earth water. Thanks to this international collaborative effort, we will be able soon to provide accurate weather forecasting, increase understanding of global climate change, as well as considerable societal benefits. Thank you for your attention, and I'll hand over to my colleague Parag Vaze from JPL.
Thank you, Thierry. Good morning, everyone. I'm Parag Vaze. I'm the project manager for NASA at the Jet Propulsion Laboratory. And I'm really excited to tell you more about SWOT, especially as Thierry described our many decades of international cooperation leading into this next generation mission. The SWOT satellite features a new measurement system called CARIN, which stands for the Ka-band Radar Interferometer. This new CARIN instrument will enable us to collect data on the height of the Earth's fresh and saltwater bodies over a very broad swath of the Earth at one time at a very high resolution, much better than any other previous satellite that is flying now. Let me illustrate this a bit more on this next animation, where you can see the SWOT satellite flying over the state of Florida and measuring the water height over the ocean, lakes, and rivers. You can see the CARIN system's two deployed antennas that are positioned about 10 meters apart, about half the length of a tennis court. These antennas have to be kept extremely stable and pointed at the same place on the Earth within a few microns, which is smaller than a human hair. The radar sends electromagnetic pulses from one antenna that reflects off the surface of the Earth and are received by both antennas at the same time. This provides a very precise measurement of the height using a triangulation technique called interferometry that lets us create a 2D map of the surface water. To measure this height, we also need very precise knowledge of the height and position of the satellite, which, as Thierry mentioned, is about 500 miles up or 890 kilometers up and traveling over 17,000 miles an hour. But to do this measurement, CARIN isn't alone, and we need a complete satellite with several supporting instruments. So let's have a closer look at the satellite, which contains many first-of-a-kind technologies. You can see in this animation the nadir module, which basically houses all of the other instruments besides the CARIN system. Once it's opened up inside, you can see the DORIS instrument, which is a precise positioning instrument. To also get all of this data down 1 terabyte per day, we need a very high performance X-band telecommunications system. And we need other instruments like the microwave radiometer that helps us correct for water vapor delay in the main radar signal that we get back, along with a traditional nadir altimeter. The CARIN instrument is the rest of the payload module. You can see the high voltage power supplies, first of a kind, 15 kilovolt system. You can also see the CARIN electronics, which include a very high performance onboard processing system, along with the radio frequency unit and gyro. All of this together, what you don't see is also a very high performance thermal management system that's keeping the whole payload module very, very stable at 5/100ths of a degree per minute. That's just some of the key technologies that we have on the SWOT satellite. One additional system that you didn't see there, and you will see in the next animation, is the main antennas for the Karen radar, which are currently, what you see here, are in a stowed configuration, folded up for launch inside the rocket. And once we're in orbit, within the first few days of the mission, we'll be deploying these antennas, which will be rotating out one by one over the course of 4 days. We'll have these masts fold out, and then ultimately we'll have the antennas, which will also fold out. Each of these antennas are 5 meters long, and then they're separated by 10 meters, as I mentioned before. After this, we'll be starting the commissioning of the overall satellite, turning on the rest of the instruments one by one over the course of the next 2 months after we launch the mission. We are, after that, we'll be doing an extensive checkout and calibration and validation of the overall satellite and in particular, the science instruments, and checking their behavior as we prepare for the science mission, which will start about 6 months after the launch. As mentioned before, the satellite is in good shape. We are at Vandenberg Air Force Base doing the final checks on the satellite. The Falcon 9 rocket provided by SpaceX is also being prepared for launch, and we're all really getting excited for a beautiful launch on the 12th of December at 3:46 a.m. Now I'm going to turn it over to my colleague Lee Fu, our project scientist, who will tell you much more about the science.
Thank you, Parag, for paving the way for me to speak about the science of SWOT. My name is Lee-Lueng Fu. I'm the SWOT project scientist. This is an emotional moment for me, as I have been working on this mission for nearly 20 years. The road from an ambitious concept to this gigantic observatory ready for launch has been long and winding. Finally reaching the moment of truth, I'm both excited and anxious somewhat. SWOT is a pathfinder mission addressing transformative questions on water and energy of the Earth system by making measurement of the elevation of the water surface of the world. Conventional radar altimeter looks straight down, sampling a one-dimensional profile of water elevation. The thrust of SWOT, however, is making two-dimensional measurement of the water elevation over a swath on each side of the satellite's ground track. The technique is called radar interferometry, as illustrated by the animation shown by Parag. As you have seen, the measurement system is complex, demanding extraordinary stability of the instrument and the precision control of the large spacecraft, making SWOT a very challenging mission. SWOT will cover the world between 78 degrees north and 78 degrees south every 21 days, providing a high-definition view of the surface water and ocean topography. The observation of surface water on land is what we need to assess the budget of fresh water. In a warming climate, the Earth's water cycle is accelerating, making water resources difficult to track and manage. Where is the water? Where does it come from? And where does it go? These are important questions we're not equipped to answer because the world's rivers and lakes are poorly sampled in many places. SWOT will make a quantum jump by making observations from space to create a global inventory of water resources. Water is also a source of hazards. If water budget out of balance, we'll have either flood or drought. SWOT data will help us improve monitoring and the forecast of such perils. The first visual, please. This image shows all the rivers wider than 100 meters to be surveyed by SWOT over the world. The amount of data from SWOT on rivers and lakes is orders of magnitude more than currently existing. For instance, only tens of thousands of lakes have been well surveyed, but SWOT will survey millions of lakes. At present, space observations only reveal the two-dimensional extent of water bodies. SWOT will add the third dimension of water elevation. As my hydrology colleagues like to say, SWOT will provide them with a pair of 3D glasses to study the dynamic movement of water bodies. The observation of ocean topography will allow us to assess the energy balance of the Earth system. This is because the ocean is a giant air conditioner for the planet. More than 90% of heat from global warming has been absorbed and stored in the ocean. Without the ocean, Earth's surface temperature would be a whopping 67 degrees Celsius, or 153 degrees Fahrenheit. Such a scorching Earth is certainly not inhabitable. The absorption of heat by the ocean takes place at small scales not presently observable from space. SWOT will make high-definition views of ocean topography, revealing the swirls of ocean currents that are responsible for heat uptake by the ocean. I will now show you an animation of the evolution of space observations of ocean topography over the past 40 years. Yeah, please show the animation. Yeah, it starts with the CSAT 40 years ago, showing a blurry view of the changing ocean topography, followed by GeoSat 5 years later, revealing some details. But until Topex Poseidon and the JSON series, in combination with other satellites, we begin seeing the ubiquitous ocean eddies, or the storm of ocean currents. But only SWOT will be able to see the small eddies and fronts that are responsible for taking heat from the atmosphere. These are the oceanic analog of thunderstorms, creating intense vertical motions, drawing down the heat from the atmosphere and stored in the deep ocean. This new information will help improve ocean models for predicting the ocean's capacity in the future to continue absorbing heat to regulate climate change. In summary, SWOT data will provide researchers better understand the ocean's role in climate change and how a warming climate is affecting Earth's lakes, rivers, and reservoirs. It addresses the energy driving climate change and its impact on freshwater resources. I would not like to turn to my colleague Ben to talk to you more about the societal benefits and applications. Ben?
Thanks, Lee. That was great. My name is Ben Hamlington. I'm a research scientist here at the NASA Jet Propulsion Laboratory. And I want to go one step further and talk to you about some of the potential societal benefits and application of the data from SWOT, which you've already heard a little bit about. If you can pull up my first animation. So this is one that Parag already showed, but as you heard from Lee, SWOT will provide nearly complete view of the surface water on Earth. Data collected by SWOT over the land, over the ocean, and where the land and ocean meet along our coastlines is going to play a really important role in informing us about our daily lives and livelihoods. And I want to walk through each of these briefly. So if we can pull up the next visual. SWOT is going to provide high definition clarity for lakes, rivers, and reservoirs across the globe. This is going to allow us to track changes in our water resources that are occurring over time. As we've heard, we know that climate change is accelerating Earth's water cycle. And what this means is there are shifting precipitation patterns where we might have torrential downpours in some locations and then extreme droughts in others. As these changes continue in the future, more communities around the world are going to be inundated with water, while in other areas, some communities may just not have enough water. SWOT data is going to be used to monitor drought conditions, improve flood forecasts, monitor reservoir volume, and assess river flow. And in doing so, it's going to provide essential information to water management agencies, disaster preparedness agencies, civil engineers, and other stakeholders who need to track water in their local areas. And I think really importantly, this is going to be done on global scales. We're going to provide data in regions where monitoring is a real challenge today. Now, shifting over the ocean, SWOT's going to provide detailed information on the smaller features that Lee was talking about, these fronts and these eddies. The unprecedented high-resolution information can then be used to improve our understanding of ocean circulation, and this then has the potential to yield important information for a wide range of industries, like the shipping industry, the fishing industry, and even for recreation. We also know that these small-scale ocean features are responsible for transporting pollutants around the ocean and then to our coasts. Examples of this would be oil spills or ocean debris following tsunamis, which we've seen some recent examples of. Precisely tracking the location, speed, and direction of potentially harmful materials will aid in natural hazard assessment, prediction, and ultimately a response to these hazards. And then finally, SWOT is going to give us data on changing sea levels closer to the coast than any of our previous satellites. Sea level around the world is rising a little bit faster every year. We know that from the data. Gaps in our available observations make it difficult to understand exactly how sea level is changing directly at the coast, where it's really the most important to understand. It may sound surprising, but along many coastlines of the world, we really don't have a good view of sea level change that is taking place. And this makes it challenging to determine what sort of future impacts these coastal areas will experience. SWOT's going to help us fill in some of these blank spots. It's going to give us insight into coastal sea levels that we can then put into computer models that allow us to improve our projections and flood forecasts. This improved information is extremely important for a number of different reasons, including supporting the adaptation efforts that are underway both here in the United States, but also on global scales. And it is also very important for national security since our military has so much infrastructure in these coastal areas. So in order to ensure that these benefits are realized, a couple things are happening already. First, SWOT's data is going to be free and easily accessible, as you already heard. But in addition to making this data easy to access for users, we're also building tools to help support users working with the data once it becomes available. And if you can pull up my last visual. So within the SWOT project, we also have something called an Early Adopters Program, which I think is really cool. A community of potential users from across the globe that continues to grow has been working with the SWOT team to learn how to quickly and effectively incorporate future SWOT data into their activities. And this is a real dedicated effort to help users understand what SWOT will provide and how it can be useful in their applications. And all this effort is designed to help communities that need the data to hit the ground running once that data from SWOT becomes available, which it was really important to us to continue to foster. So while SWOT is going to answer many important science questions about water here on Earth that Lee and others have talked about, it also has the potential to be really transformative in its ability to support those relying on water for their daily lives and livelihoods. And this includes applications across land, ocean, or coastal regions, and it's going to produce relevant and important information for almost everyone here on Earth. Thanks, and then back to you, Marina.
Thank you so much, Ben, and thank you to our speakers. We are now ready to take media questions. Remember to press *1 to get put in the queue, and please direct your questions to one of the panelists. We're also taking questions through the hashtag #AskNASA, and we'll start with social media questions right now. Dee on Twitter asks, will SWOT be scanning for underwater resources? Would you like to take that, Ben?
Sure. Yeah, so SWOT's going to see the surface water here on Earth, right? So it gives us almost complete survey of surface water. We're not going to see these underwater features, at least not directly. Maybe we can infer some of them from the data, but really the benefit of SWOT is being able to see the surface water.
Thank you. Gaurav on YouTube asks, will we be able to determine the accelerated rate of warming of oceans and or the increasing melting of glaciers and polar regions due to global warming via SWOT? Lee, would you like to take that?
Yes, absolutely. SWOT will make observations, surface water, and also ice, including sea ice and land ice. But most important contribution of SWOT is to understand the ocean's role in climate change by absorbing most of the heat dumped to us by global warming. So it really helps us to understand the mechanism of climate change and its evolution into the future. And of course, it also measures the stress of what climate change imposed on water resources. So it's not to monitor climate change for, because it's a 3 years mission, the primary mission. But the most important thing is to provide a high definition view of both ocean circulation and the surface water so that we can understand how climate change will evolve and how we're going to deal with these coming changes. Thank you.
Thank you, Lee. We'll head to our callers now. Caller number 1, Gino Harrell from Radio Canada. Good morning, Gino.
Good morning. Can you hear me?
Yes.
Good. I wanted to know how essential Canada's role was and Canadian Space Agency's role was in building this mission. I understand there were characterization having to take place, but also in the Canadian instrument content on the satellite to be launched.
Parag?
Yeah, really great question. Thanks for bringing that up. So on SWOT, NASA has a bilateral cooperation with the Canadian Space Agency, and CSA is providing a very important piece of the Karen instrument, which is what's called the Extended Interaction Klystron. It's the high-power transmitter that Karen uses to actually transmit its signal. And this has been an extremely important contribution on SWOT. This is a piece of equipment that really doesn't exist anywhere except actually from one of the partners companies in Canada. We've worked very closely with Canadian scientists as well who are participating in many science activities, particularly looking at, of course, the millions of water bodies and lakes and rivers in the Canadian northern continent. And so on the instrument, we have a very close collaboration. It's a very important piece of equipment, particularly for the Karen instrument, and we're looking forward to working further with our Canadian partners.
Thank you, Parag. Our next caller is Megan Bartels from space.com. Hello, Megan.
Hi, thanks so much for taking my question. I'm not sure exactly who this is best suited for, but a few of you have mentioned SWOT will be the first satellite that can see all of the water on Earth. Could you talk about why none of the satellites that are currently in orbit or have been in orbit can do that, and sort of what makes that possible for SWOT where it's not possible for those satellites? Thanks.
Yeah, I think I can take on this question. It's a great one. And before SWOT or even altimetry, the primary way to observe the Earth's water from space is optical instrument. So there's a high definition view of the two-dimensional extent of waters, but we don't know how much water is there, how the water is flowing. So radar altimetry 40 years ago actually revolutionized by adding the third dimension of water elevation so that we do ocean circulation and the land water monitoring. However, all this nadir looking or the radar looking straight down, taking only one-dimensional profile. So it takes months to piecemeal the Earth. SWOT, every 21 days will sample the entire Earth without gaps. The elevation under this high definition view will reveal ocean circulation never observed before. That's responsible for absorbing heat to protect us from excessive warming, but also provide detailed information for water managers. The third dimension, as I mentioned earlier, is like a 3D glasses. In the past, you don't have this perspective of the elevation, but for the first time, SWOT will provide this third dimensional information. Therefore, we can study hydrology in a quantitative manner, tracking the flow, calculating the rate, so do the water budget management and the monitoring.
Thank you so much, Lee. We'll go back to social media. Paul Smith on Facebook asks, what effect is the draining of the world's aquifers on climate change and rising internal temperatures of the Earth? Lee?
Yeah, the SWOT basically observes surface water, but the aquifer, the groundwater, of course, is the biggest reservoir of fresh water on Earth. And so the water usage, primarily, you go through groundwater, which is measured by other satellites, but the surface water is directly available to us for water usage and also create hazards. And as far as the draining groundwater and the global warming, I'm not quite sure the essence of the question.
Is the draining of the world's aquifers on climate change and rising internal temperatures affecting the Earth?
That's really not my expertise, but I don't think so.
Thank you, Lee. Next question from Karen on Facebook asking, is sea level rising or is the land sinking?
I can take
Ben?
that one.
Yes.
Yep. Well, it's both, right? So in a lot of our coastal regions, we see subsidence, which contributes to sea level change. We call it relative sea level change. So it's the movement of the ocean relative to land. So subsidence is certainly a factor. We see that along the Gulf Coast of the United States. It's particularly important there. But on global scales, pretty much everywhere, the ocean is indeed rising as a result of global warming. So we know the contributors that lead to this increase in sea level. Both the main ones on global scales are melting ice that's located on land and then thermal expansion of the ocean as it continues to absorb heat and expand. So yes, the ocean is certainly rising, causing sea levels to go up along our coastlines. Subsidence kind of exacerbates that signal that we see from the ocean.
Thank you so much, Ben. Next is Stop, Listen, Think on YouTube. Congratulations to be able to see this through after 20 years. I know it's difficult to do. Who is handling the bus? Parag or Thierry?
I think Thierry
Yes.
should take that.
Let me take the question. As I mentioned before, when we set up the work share between the US and France, France proposed to build up the spacecraft bus based on the Thales linear space experience. So they built up a high performance bus to cope with the demanding requirements from especially the carrying instruments. So effectively the spacecraft has been built by France and Thales Industry, and Thales also did the integration and the testing of the whole satellite in Thales CAN.
Thank you, Thierry. We're going to go back to the phone lines to Megan Bartels, who has a follow-up question from space.com. Hello, Megan.
Hi, thanks so much for taking a second question. I'd love to hear from each of you, sort of with 1 month to go before launch, what is left to tick off and how are you all feeling?
I can go first. It's Parag. So we're doing, as I said, the last checks, of course, with the satellite. We're nearly done with that, and we have to basically mate the satellite with the rocket and prepare that. It's a fairly straightforward operation, but one that requires again multiple organizations and teams of people working together. They're really motivated, excited, because it's again a culmination of many years of work towards the launch. But we have a big team of people also preparing for the operations of the satellite, and they've been working hard for many years as well, preparing for this moment. And they are basically going through rehearsals to get trained and ready for the big moment just after the launch, where they take over. And so the team is very excited. I think they've invested many years of their personal career and sacrificed for this moment, and have a personal connection with the mission, and of course with Earth science, because this is something very important to the people, not only working as engineers, but really working as people who care about the Earth and what this mission might mean for that future.
So I can go next. So we are at NASA headquarters. We're very, very excited about these missions because we're going to add another satellite to our fleet to make sure we observe the Earth in all different directions to understand what's all the system with the Earth to be able to protect our home planet. Thank you.
Terry?
On the French side, of course, we are also excited with preparing for the launch because France has invested a lot of efforts and resources in this mission. This is actually the biggest cooperation mission of our country. And of course, because we've been involved either in the space for the flight system, building up the spacecraft bus, and doing the integration of the satellite, but also we are doing the operations in Toulouse, France. We have a big team there currently preparing for being ready for the launch and early orbit operations. Everyone is, of course, today concentrated on their objective is to make that mission work.
Lee?
All right. Yeah. Hi. As I said earlier, that this mission's 20 years in making. This long endeavor is long and winding. And as you have heard, this satellite is huge. The complex system of measurement is first of its kind, unprecedented. So at this moment, my emotion is a mixture of excitement, thrill, and also a bit of anxiety.
And Ben?
Then I can go last here. Yeah, I mean, so I sit firmly on the science side, and unsurprisingly, I'm also excited about the potential for what comes after launch once SWOT starts sending down some data. I mean, we heard words in this panel like game changer, pathfinder, transformative, and I don't think these are just buzzwords. I think there's the real potential for SWOT to provide information both for science and application it's really just going to provide an enormous amount of potential and opportunity for us to understand this data and how it can be useful both for science and application. So similar to the other panelists, I'm very excited about what's to come.
Well, thank you so much for your questions, and thank you to our panelists for joining us today. I can really feel your excitement, and I'm very happy for you. SWOT is scheduled to launch from Vandenberg Space Force Base in Central California on December 12th. For more updates on the mission, go to swat.jpl.nasa.gov. On that site, you can find a list of early adopters to find out if groups in your area are going to be using SWOT data in local projects. You can also follow at NASA Earth and at NASA JPL on social media and use the hashtag #TrackingWorldWater. We're also going to be doing a live social media Q&A about SWOT this Thursday, November 17th at 9:30 a.m. Pacific with mission team members. You can tune in by following our JPL YouTube, Twitter, or Facebook accounts. Thanks so much for joining us today at NASA Earth Science. Your home is our mission. Thanks for watching.